If you haven't read this second example or question 10, then pause the video and do so, because you can see that I've highlighted things and answered many parts. If you don't have a good understanding of the question, then you're not going to get the most out of this solution. So, yeah, please do that if you need to. Now, you'll see that I've actually highlighted particular parts of the question. So as Eleni has, she starts from 8 metres, and we can see that at time 0, she's already at 8, and she reverses to the gate. So they've obviously put the gate as their reference point, or 0, if you like, and she then pauses. So I've highlighted that pink. She then drives forward for 20 metres from the gate, 20 metres away, and she pauses again. She then reverses to her starting point, which was 8 metres from the gate. So yes, the graph shows that we don't have a formula, but it's asking what is her average velocity in part 1 during the first 8 seconds. So we know that basically average velocity is the slope of the chord, and we can see that that is negative, and yes, you can see I've got a negative. The definition for average velocity is change in displacement. So she ended up at 0 displacement. Subtract 8, where she came from, where she ended minus where she came from, and the difference in time was 8 seconds, and it gives you -1. Part 2 wants the average velocity while she's driving forward. She only drives forward in this one section from the gate to 20 metres away. So we've got the average velocity is where she ends up minus where she started, over the difference in time, which is the difference between 17 and 12. 20 divided by 5 is 4, and it's a positive, which we'd expect. She's moving in the positive direction, away from the gate. Average velocity in part 3, while she's reversing the second time, it's just this short black section. So where does she end? She ends at 8. She started at 20. We know that the average velocity is the gradient of the line. So where it can see the gradient of that line is a negative. Like I said, she ends at 8, started at 20. That gives -12 divided by 6 is -2. Part B says find the total distance she travelled and her average speed over the 30 seconds. So the total distance. Now, again, we don't have a formula for total distance. We just take it from the information that's given. So in her first reverse, she travelled 8 metres. Going forward, she travelled 20 metres. Then in her second reversing section, she goes from 20 down to 8, which means she passed through 12 metres. So all up, she's got 40 metres she travelled. And then it says find her average speed. So her average speed is her total distance divided by the time, which was 30 seconds, over the entire 30 seconds. So that is 1.3 repeating metres per second. C says find her change in displacement and then average velocity over the 30 seconds. So her change in displacement, delta displacement, change in displacement. She went from 8 and she finished at 8. finished at 8, started at 8, she's got 0 displacement. We know that that then means that her average velocity will also be 0, because it's the change in displacement divided by time. 0 divided by anything is 0 meters per second. And then so you can have an average speed of 1.3, but an average velocity of 0. D, just asking for her average speed if she'd not paused at the gate and at the garage. What do we know is the definition of average speed? It is the total distance divided by the time. Now, the distance she will have travelled won't change. It's only the time that will change. If she had not paused, that's the only change. So the total distance she travelled was 40, and we had that, it took her 30 seconds. Her pause time here is 4, and her pause time here is 7. Is that right? Yep, 7. And 4 is 11 seconds. So take 11 seconds out of 30 and you're down to 19. So whatever 40 on 19 meters per second would be, and I would just leave it like that. 19 is prime, so I'd just leave it like that. I think you're right now to do the questions from exercise 5A.